Hi students, my name is T. Rashekar, working as a lecturer in civil engineering, SRRS Government Polytechnic Sircilla. First year, first sem, basic surveying subject, CE 105 subject code. And from the compass surveying chapter, we are going to learn today concept of forebearing, back bearing and included angles. Objectives. On completion of this lesson, you would be able to understand the concept of forebearing, back bearing, and calculation of included angles. So this is very important. What is forebearing and back bearing and included angles? So here, when the bearings of two lines are measured from station, and when the bearings of two lines are measured from different stations, so from some same station and from different stations. So once we see, that is definition of bearing of a line, systems of representing bearing, whole circle bearing and quadrantal bearing, and conversion of whole circle bearing into quadrantal bearing, and conversion of quadrantal bearing into whole circle bearing. These topics we have seen in our previous videos. So now let us see forebearing and back bearing. So this is a principle very important in the compass surveying. So here every line may be defined by two bearings. So here every line, whatever the readings we are seeing, it will be defined by two bearings. So each one observed from other end of station. So whatever the reading you are observing, so that will be the other end of station. The bearing in the progress of survey is called forebearing. So that means the bearing which we are seeing to the forward direction. So this is the diagram. So if this is a compass cherished point, from here if you are seeing to the another point, so this direction is called forebearing. And when the point you have seen this point at the, suppose this is the A and this is the B. Okay. So from A to B we have sighted a point, and from B to A if you sight again, so in this way, so this is called back bearing. That means if this is seeing in the backward direction, so the bearing in the opposite direction of the progress of survey is called back bearing. So in simple, the reading whichever first we are seeing to the opposite direction is called forebearing, and the reading which you are seeing to the from that point to the back direction is called back bearing. So let us see, the bearing in the direction from A to B is forebearing of AB, say alpha, and this is simply called bearing of AB, and the bearing of the line AB in the direction from B to A is back bearing of AB, say beta. So here you can see in the directions, so north and south direction. So this is the station point A. So the first direction which we are seeing to the point B, this is forebearing, and again north and south direction. So if you are seeing back to the from B to A, okay, so this is called the direction back bearing. This we will call it as back bearing. And again from here if you see the direction, so A to B it is completed. Now B to C, the direction which is there, so here again it will be the forebearing, the direction which is there, so it is forebearing. So that means up to here it will be there, this will be the forebearing. And again from C to D, if you see this one, it is called forebearing. And if you see again from C to B, then this is called back bearing. And if you see from D to C, it is called back bearing. So this is a process of seeing the directions forward bearing and back bearing. So refer to figure 1. Let the forward bearing of a line AB is equal to alpha degrees. So where is the figure 1? This is the figure 1. Okay, this is the alpha beta. So back bearing of BA is equal to beta degrees, or beta is equal to 180 degrees plus angle SBA. So what is SBA? So this is the angle SBA. So this is the angle where we can see the SBA angle. That is, in the case of beta is 180 degrees plus angle SBA. So to get this beta angle, that is including 180 degrees plus angle SBA, is equal to angle BAN. That is called this one, angle BAN. So it is equal to alpha plus 180 degrees. Therefore, back bearing is equal to forward bearing plus 180 degrees. Here we can see N dash S dash N S. So this is the point A. From A to B, this is forward bearing, and from B to A, it is back bearing. It is determined as X, and it is also X, and it is alpha, and this is beta. Now consider the bearing of BA as forward bearing is equal to beta. Then alpha is equal to 180 degrees is similar to angle S dash AB. So here this is angle S dash, this is S dash AB. So this is the angle we will get. So this angle is called 180 degrees plus equal to AB, and that is 180 degrees is similar to 360 degrees, similar to beta. Beta is similar to 180 degrees, or we will write back bearing is equal to forward bearing is similar to 180 degrees. This will be the second equation. So equations 1 and 2 may be combined into one equation, that is back bearing is equal to forward bearing plus or minus 180 degrees. Okay, in these cases we can do whether if the 180 degrees is value is more than 180 degrees, we have to do minus. If less than 180 degrees the value is there, we have to do plus. Next, use positive sign if the forward bearing is less than 180 degrees, and use negative sign if the forward bearing is more than 180 degrees. Not back bearing, only forward bearing. And here the rule is applicable for whole circle bearing system only. Remember, so here the rule is applicable only in the whole circle bearings only. Whereas if quadrantal bearings are given, convert them into whole circle bearings. So like this we have to do the calculation. If the quadrantal bearings are given, then we have to convert them into the whole circle bearings and apply the above rule and reconvert into quadrantal bearings. So we have to apply the above rule and we have to reconvert into the quadrantal bearings, or in case of quadrantal bearings, the numerical value of forward bearings and back bearings are same. So but the cardinal directions are reversed as follows. So what are the cardinal directions? That is, for north substitute south and vice versa. For east substitute west, Okay, for the following example illustrate all the above cases. So that is example number 1. Let us see. The following are the observed forebearings of some lines in a traverse. Find their back bearings. We have to find the back bearings. So AB 42 degrees 30 minutes, BC 135 degrees 15 minutes, CD 212 degrees 30 minutes, DE 285 degrees 45 minutes. So here A, B, C, D, E has the 5 station points are there. The 4 readings are there. So let us see here. The first ever the reading which is there, that is AB, is 4 bearing. So a 4 bearing of AB is equal to 42 degrees 30 minutes. So as per the, to get the back bearing of AB, what we have to do, it is less than 180 degrees. So 42 degrees 30 minutes plus 180 degrees, we will get the back bearing of AB is 322 degrees 30 minutes. And if you see the forward bearing of back BC, that is 135 degrees 15 minutes given. So back bearing of AB is equal to 135 degrees 15 minutes plus 180 degrees. So this is equal to 315 degrees 15 minutes. So these are all calculating the back bearings. And the next one, you can see the diagram. For the first one, it is given 42 degrees 30 minutes for bearing. So that is from the station point A to B. So it is in the northeast quadrant, first quadrant. So this is a 4 bearing we have seen. To get this back bearing, so what we have to do here, we have to add this angle, the remaining angle we have to add. So that will be the 42 degrees 30 minutes plus 180 degrees. We will get the angle of this one. So it will be of this tail only. Okay, so the angle will be off up to here only, 40 degrees. So the remaining angle how much will be there? That suppose you think 180 degrees. Okay, so if you think 180 degrees, then the angle we will get the back bearing is called 222 degrees 30 minutes. So same like that in the BC also, the 4 bearing was given 135 degrees 15 minutes. So it is less than or equal to 180 degrees. So if you see this angle is so like this. So we got this one. So if this is 135 degrees 15 minutes here. So this angle is, suppose it is the 180 degrees. So if we do plus, we will get the remaining angle of back bearing. So that is 315 degrees 15 minutes. So let us see now third one. So these problems are very important. Now these are the basic calculations we are doing. So by going on into the problems, there will be the critical calculations in the compass surveying. So let us see here. 4 bearing of CD is equal to 212 degrees 30 minutes. So here back bearing of CD is equal to 212 degrees 30 minutes. It is similar to 180 degrees. So what we have to do? It is 32 degrees 30 minutes. So that means the 212 degrees 30 minutes, it is minus 180 degrees, because it is more than 180 degrees, then we will get 32 degrees 30 minutes. So meanwhile 4 bearing of DE is equal to 285 degrees 45 minutes. Then back bearing of DE is equal to 285 degrees 45 minutes minus 185 degrees, 180 degrees, we will get 105 degrees 15 minutes. So if the value is less than 180 degrees, we are doing plus. If the value is more than 180 degrees, we are doing minus. So here, this is the point D and C, C to D. So C, it is given 212 degrees 30 minutes. So if you want to find out this angle, that is the back bearing angle, so we have to take this angle as 180 degrees and 212 degrees minus 180, then we will get the angle, this one. And here from D to E again, so the forebearing angle was given 285 degrees 15 minutes. So the remaining angle is, suppose you can see, 180 degrees. So 285 degrees minus 15 minutes, if you do minus, then we will get the back bearing angle. So that is 105 degrees 15 minutes and 32 degrees 30 minutes. So this is 32 degrees 30 minutes and this is 105 degrees 15 minutes. Let us see the now example number 2. The forebearing of AB is north 30 degrees east. Find its back bearing. So if it is AB is north 30 degrees east, we have to find its back bearing. Solution: the forebearing of AB is north 30 degrees east, then the back bearing of AB is south 30 degrees west. So solution by converting into whole circle bearing system. The forebearing of AB is north 30 degrees east. So the forebearing of AB is in whole circle bearing is equal to 30 degrees. Then the back bearing of AB is in whole circle bearing, that is 30 degrees plus 180 degrees is equal to 210 degrees. So by reconverting into quadrantal bearing, the back bearing of AB is south 30 degrees west. So now case 1, calculation of included angles. Up to now we have done forebearing and back bearing. Now let us see the calculation of included angle. What is included angle? The interior angles which are taken inside is called included angles. In case 1, when the bearings of two lines measure from same direction from their point of intersection. So let FB of AB is theta 1 and AC is theta 2 as shown below. So here you can see A and B point, so which is there. So from A to B we are citing. So here AB is theta 1 and AC is theta 2. This is another angle and this is another angle. So angle BAC, so that means from this one, like this, angle BAC, angle BAC, it is equal to bearing of BC minus bearing of AB. That means bearing of BC minus bearing of AB. So this is equal to theta 2 minus theta 1. So bearing of preceding line minus bearing of succeeding line. So we will be coming like this, bearing of preceding line minus bearing of succeeding line. So now next is case 2. So we have to follow these cases. So this is case 1. In the case 1, it is in the angle ABC, theta 2 minus theta 1, bearing of preceding line minus bearing of succeeding line. Let us see case 2. When the bearings of two lines measured from different stations. When the bearings of two lines are measured from different stations, that is A and B and C. So this is the theta 1 and theta 2. So in this case, express the bearings of two lines as if measured from single station and apply the formula. So here these are the lines as if measured from single station. They will apply the formula. Thus find back bearing of AB. So then angle B is equal to 4 bearing of BC minus back bearing of AB. So this is the here angle B is equal to 4 bearing of BC minus back bearing of AB. Note, when two lines meet at a point, two angles, the interior and exterior angles are formed. So up to now we have seen that only the included angle, but when two lines meet at a point, we will form a two angles, that is interior and exterior. So the sum of these angles is equal to 360 degrees. So if the calculated interior angle is greater than 180 degrees, it is called exterior. And the interior angle then is 360 degrees minus exterior angle. If the bearing are given in quadrantal bearing system, convert them to whole circle bearing system and then apply the above rules. As we see in the first note, so when the two angles are meeting at a point, okay, so that is called interior and exterior angles, whereas all the angles will be in the 360 degrees only. So within the 360 degrees closed, and if the interior angles are greater than 180 degrees, it is called exterior. So if the interior angle is 360 degrees, it is similar to exterior angle. And here, if the bearing of given in quadrantal bearing system, we will convert into the whole circle bearing system. Now, the rules, the following numerical examples illustrate the following cases. Note, this symbol indicates difference. This is the indication of difference. Therefore, whether we subtract bigger bearing from smaller bearing, or so we should take only numerical value into consideration. So now see example 3. Find the angle between the lines OA and OB given their bearings as below. 35 degrees 30 minutes and 150 degrees 45 minutes. Solution. Draw the sketch. From sketch, angle AOB is equal to bearing of OB is similar to bearing of OA. So that is 150 degrees 45 minutes minus 35 degrees 30 minutes is equal to 115 degrees 15 minutes. So this is the sketch. We have given the value, that is 35 degrees 30 minutes. So we have to find the value. 35 degrees 30 minutes is given. So from this, to get the value, we have to do plus 180 degrees. We will be doing minus, that is from 150 degrees 45 minutes. From both angles, we will get the angle is 115 degrees 15 minutes. The next example 4. Find the angle between the lines OA and OB given their bearings as below. So 20 degrees 15 minutes and 320 degrees 30 minutes. Solution. Draw the sketch. From the sketch, angle AOB is equal to bearing of OB minus bearing of OA. So this will be the minus. So bearing of OB is 322 degrees 30 minutes minus 20 degrees 15 minutes. It is called 303 degrees 15 minutes. So it is greater than 180 degrees. Then it will indicate exterior angle. So if less than 180 degrees, it will indicate interior angle. If more than exterior angle, 180 degrees, it will extend exterior angle. So it is called 56 degrees 45 minutes. So therefore, interior angle AOB is equal to 360 degrees, similar to 390 degrees 15 minutes. This is a diagram. 20 degrees 15 minutes, it is in the first quadrant. 320 degrees 30 minutes, it is the fourth quadrant. First, second, third, fourth. So here, example 5. Example 5, we have to find the angle between the lines OA and OB. Given their bearings as below. 115 degrees 15 minutes and 250 degrees 45 minutes. Solution. Draw the sketch. For every question we have to draw the sketch compulsory so that we can understand very easily. That is, from sketch, angle AOB is equal to bearing of OB minus bearing of OA. So 250 degrees 45 minutes minus 115 degrees 15 minutes, we will get 135 degrees 30 minutes. So this is the diagram. 250 degrees 45 minutes minus 115 degrees 15 minutes. So then we will get the angle of 135 degrees 30 minutes. The next one is example 6. The bearings of AB and BC are given below. Find the angle between the lines. (152 degrees 15 minutes and 70 degrees 30 minutes). Solution. In this problem, the bearings of lines are not from point of intersection. Therefore, express the bearings as if measured from point of intersection. So then apply the rule. So here 115 degrees 15 minutes was given and 65 degrees 30 minutes was given. So if you do the 115 degrees 15 minutes, the back bearing we will get. So that is 152 degrees 15 minutes plus 18 degrees, we will get 332 degrees 15 minutes. So note that bearing of BA is nothing but back bearing of AB. So that we will call back bearing of AB. The next bearing of BC is equal to 70 degrees 30 minutes. So included angle B is equal to 332 degrees 15 minutes minus 70 degrees 30 minutes is equal to 261 degrees 45 minutes is greater than 180 degrees. It indicates the exterior angle. So therefore, included angle of B is equal to 360 degrees is similar minus 261 degrees 45 minutes. Then we will get 98 degrees 15 minutes. Next one, example 7. Let us see. The bearings of AB and BC are given below. Find the angle between the lines. 65 degrees 30 minutes and 115 degrees 15 minutes. Solution. Bearing of AB is equal to 65 degrees 30 minutes, and whereas bearing of BA is equal to 65 degrees 30 minutes plus 180 degrees. This is equal to 245 degrees 30 minutes. Note that bearing of BA is nothing but back bearing of AB, and bearing of BC is equal to 115 degrees 15 minutes. So included angle B is equal to 245 degrees 30 minutes is minus 115 degrees 15 minutes, that is equal to 130 degrees 15 minutes. So this is the included angle of B. So here we can see the diagram. 152 degrees 15 minutes, it is for bearing. So we have done the 245 degrees 30 minutes minus 115 degrees 15 minutes. So then we will get the angle. So this is for bearing and this is the back bearing. Next one, example 8. Find the included angle B given the following bearings. Bearing of AB north 15 degrees 15 minutes east and bearing of AC north 87 degrees 10 minutes east. Solution. Step 1. Convert the given quadrantal bearings into whole circle bearings. Step 2. Apply the formula as usual. Whole circle bearing of AB is equal to 15 degrees 15 minutes and whole circle bearing of AC is equal to 87 degrees 10 minutes. So angle BAC is equal to whole circle bearing of AC minus whole circle bearing of AB. So 87 degrees 10 minutes is similar to 15 degrees 15 minutes. We will get 71 degrees 15 minutes break. This is the answer. Next, example 8. Find the inclined angle B given the following bearings. That is bearing of AB N 12 degrees 24 minutes east and bearing of AC south 52 degrees 30 minutes east. So same like that, convert the quadrantal bearings into whole circle bearings, and the second apply the formula as usual. So whole circle bearing of AB is equal to 12 degrees 24 minutes. Whole circle bearing of AC is equal to 180 degrees minus 52 degrees 30 minutes. So these bearings and angles are calculated for the taking the areas in two methods, that is closed traverse and open traverse, and this is called 127 degrees 30 minutes. So angle BAC is equal to whole circle bearing of AC minus whole circle bearing of AB. So it is equal to 12 degrees 24 minutes minus 127 degrees 30 minutes is equal to 115 degrees 6 minutes. So it will get in the negative. So we have to write in the positive form. Then example number 9. The bearing of line AB is north 62 degrees 45 minutes east. CA is north 28 degrees 15 minutes east. Find angle BAC. So convert the above bearings into whole circle bearings and apply the rule. Whole circle bearing, if AB is equal to 62 degrees 45 minutes, bearing of CA is equal to north 28 degrees 15 minutes west. So if you want to draw the diagram, so like this, it is showing the north. So in which quadrant it is the first quadrant, 60 degrees 45 minutes east. So draw this. This is the point A and this is the point B. So from here it is 62 degrees, whereas this is called northeast. And another angle northeast only 28 degrees 15 minutes east is there. So this will be here. That will be the another angle. So two angles were given here. So bearing, the whole circle bearing of AC is equal to, so 28 degrees 15 minutes plus 180 degrees, we will get 208 degrees 15 minutes. So here angle BAC is equal to bearing of AB minus bearing of AC, that is B, and this will be the C. So 62 degrees 45 minutes minus 288 degrees 15 minutes. This is equal to 145 degrees 30 minutes. So from the above two examples, we can conclude that in a transverse angle between two successive lines, back bearing of preceding line minus bearing of succeeding line. So for summary, in this class we have learned today concept of forebearing, back bearing. Difference of forebearing and back bearing is always 180 degrees. Calculation of included angles. So when the bearings of two lines measure from same station and when the bearings of two lines measure from different stations. So these are the topics we have discussed today. So angle between two lines, that is bearing of preceding line minus bearing of succeeding line. So if the angle calculated greater than 180 degrees, it indicates exterior angle. If the interior angle is 360 degrees minus exterior angle. Okay, to get the interior angle we have to do from 360 degrees minus exterior angle. So this is the formula we have to remember. Okay, thank you, have a nice day.